Okay, let's see question 24, square root. So a square root of 121, that's 11, right? Because 11 square equals to 121. So square root of 121 equals 11. And this one can be written as square root of 36 in the numerator, square root of 25 in the denominator. So square root 36 is 6, square root 25 is 5. Cubic root of 27, that's a 3 raised by 3, then cubic root. So it's just a 3, right? Because 3 raised by 3 equals to 27. Well, this one, the index is a 3. So we see that's a negative 1 over 5 raised by 3. So this one equals a negative 1 over 5. This one, because this index is 2, so we have to change. So negative 7 squared is a 7. Same as 7 squared. So it's a 7. Okay, because negative sign we can understand as a negative 1. Negative 1 being squared become positive. But this one does not exist in real number, right? Because this is a negative, this is negative 81. Oh, you know what? Right, since we have learned complex numbers, right? So this is square root of square root of negative 1, which is 9. Okay, 9i or I9. Let's see this one. This one, the negative sign is in front of the radical sign. So just keep the negative sign. Then 64, so 2 raised by 6 is 64. So that equals to 2 raised by 6, 6 root. So just equals to negative 2. The negative signs outside, the radical signs, we keep writing it. Now 5, the power and the index are the same, so we get a negative 23. Negative 23, that becomes positive 23. Okay, 25, we want to find the domain of the functions and evaluate at a given point. So this is a square root function. Square root function, the function is defined under real numbers. So we see the radicand has to be non-negative because the index is 2. I solve this, so we get a 6 greater than or equal to 2x. We divide by 2 on both sides. There's a 3 greater than or equal to x, but normally we start with the variables. We see x is less than or equal to 3. That's the domain. If we want to use the interval notation, we see, okay, that's from negative infinity up to 3, and including 3. Evaluate at x equals negative 5. So we write as f of negative 5 square root of 6 minus 2 times 5. 2 times negative 5, right? So then we have square root of 6, negative 2 times negative 5, that's positive 10. Square root of 16, that's 4. So f of negative 5 is 4. Let's see second one. Second one, we take the radicand, we see, okay, that has to be non-negative. That means x is greater than or equal to 8. Use interval notation starting from a including a up to positive infinity. Then we evaluate at 9. So f of 9 equals to square root of 9 minus 8. Or 9 minus 8 is just 1. Square root of 1 just 1. So for C, the index is a cube. So the domain for the index is 3. So domains are all real numbers. Okay, when the index is odd, the domain of the function is all real numbers. Then we evaluate at -7. A cubic root of 6 minus 3 times -7. So that's cubic root of 6 plus -3 times -7 is positive, plus 21, which is a cubic root of 27. And that's 3, right? Because 3 cubed is 27. Let's see this one. Now the index is even number again. So we see the radical 6x plus 3 cannot be negative. So that means 6x has to be greater than -3 divided by 6 on both sides. That means x value has to be greater than or equal to -½ Use the interval notation, get this. Then we want to evaluate at x equals to 13. So we have a 4th root of 6 times 13 plus 3. 4th root, 6 times 13, 3 times 6, 18. 10 times 6, 60, so 73. 78. 78 plus 3. Oh, that's 4th root of 81. Or 4th root of 81 equals to 3, because 3 raised by 4 is 81. Okay, let's see 26. We want to simplify. We want to simplify this radical expression. So we see A inside is a perfect square, right? It's x minus 3 squared. Square root cancel each other, but we want to make sure it's positive, so we put the absolute value sign around x minus 3. And the negative sign is in front of the radical sign. So we have the inside radical, we have x plus 2 squared. Square root cancel each other. We also need to put absolute value around x plus 2 to make sure that's positive. 243, so the index is 5, odd number, so we still get negative sign. 243 is 3 raised by 5. So 3 raised by 5, then with index 5, that's just 3. Then 5 raised by, y raised by 5 with index 5, that just becomes y. So negative 3y. This one is 4. This one is 4. Right? And the 625 is 5 raised by 4. Because 5 squared 25. 25 times 25 is 625. And then we want to make sure this x plus 3 is positive. So we put an absolute value signs around it. Let's see 27. We want to simplify. So let's rewrite 64 as a 4 cube. Right? 4 raised by 3 is a 64. Then 2 divided by 3. So we have 2 layers of exponents. We multiply them. 3 times 2/3. So 3 numerator, 3 denominator cancel out. So I get a 4 squared, which is a 16. This one we get a 1 over the power is, so 3, the numerator is the power, so 25 raised by 3. Then this 2 denominator is the square root. Right? So we get a 1 over, or square root 25 is just 5, 5 cubed. So 1 over 125. So let's see C. Same base, so x, we just add the exponents for multiplication. So 2 over 7 plus 4 over 7. 2 plus 4, that's 6. So x raised by 6 over 7. So usually we write it as radical sum. X raised by 6, the numerator is power, the denominator is the index. Half means square root. square root everybody inside, right? So let's write that. So, or we could do this. So 64, because this is only half, 64 is a squared. So get a squared times half, that just becomes 1. Then x raised by 6 times half, y raised by 3 times half. So we simplify 2 times half, that becomes 1. So we just get 8. X raised by 6 times half, 6 times half, that's 3. So x raised by 3. And y raised by 3 times half. So 3 times half, just y, and the square root of y, right? Because y raised by 3 over 2 is y raised by 1 plus half. Y raised by 1, just y. Y raised by half is the square root of y. Let's see, E and F. E, let's simplify. Can we simplify inside? Actually not. We have X, we have Y, we have Z. So, but this Y raised by negative exponent, so we can move to the denominator, right? So I have X raised by 4 over 5 divided by Y raised by positive 3 over 5 in the denominator times Z raised by 2 over 5, then raised by 3. Now we can distribute 3 to the power of x, y, z. So x raised by 4 over 5 times 3, that's 12 over 5. Y raised by 3 over 5 times 3, that's becomes y raised by 9 over 5, because 3 times 3 is 9. Z, 2 times 3 is 6, raised by 6 over 5. All the numerator is all bigger than the denominator. So we can simplify it. So the numerator will get x squared, right? Because 12 is 10 plus 2. 12 is 10 plus 2. Then we have a fifth root of x squared. The denominator we have 9 is 5 plus 4. So we write as y, fifth root of y to the fourth power. 9 over 5, right? So 5 over 5 plus 4 over 5. And z term, we have z, because z 6 divided by 5, so 6 equals to 5 plus 1, so we have z square root of z. Fifth root of z, no square root. It's all fifth root. So now we can write the fifth root together. And all side together. All side we get x squared, y to the fifth power, and z. Then inside, under the fifth root sign, we have x squared divided by y to the fourth power and z. So this is the simplified version. Now let's see this one. This one, we see this is a negative sign. So let's apply that. So negative sign is telling us to flip over the numerator and denominator. So y to the 3 over 4 becomes the numerator, and 2x cubed becomes denominator. Now raised by positive 1/3. We can just distribute, right, 1/3 to the exponents. So numerator will have y 3 over 4 times 1/3. And denominator will have 2x cubed, or 2 raised by 1/3 first, and x cubed times 3 times 1/3. So simplify the numerator, we see 3 cancelled, so we have 1/4. 1/4 we read as fourth root of y, right? Because y raised by 104, that's its meaning. Then in denominator, we have cubic root of 2. And the x raised by 3 times 1/3, this just becomes 1. So we get this. Okay. We get a cubic root of 2 in the denominator. Then x raised by first power, because 3 times 1/3, just 1. So just x. Okay, let me take a break. Then we continue.